right. So today we are going to be looking at stoichiometry. Stoichiometry is essentially our way of analyzing chemical reactions quantitatively. Have y'all heard the difference between quantitative and qualitative?
Sure.
Hopefully that kind of comparison rings a bell. You should have looked at something like that last semester, even in biology probably. Qualitative, that's using words, descriptions, colors, things like that. Quantitative, which is where chemistry really, really thrives. Quantitative, quantity, we're looking at numbers. In stoichiometry, we're essentially comparing the amount of reactants it takes to make a certain amount of products. Or, what we're going to really practice is if I have a certain amount of reactants, how much product can I make from that? Now, this unit is going to be a major throwback to last semester for you guys when you talked about the mole. You guys should have done a lot of different things with the mole. Converting moles to grams, grams to moles. Moles to molecules, molecules to moles. Grams to grams, grams to molecules, and vice versa. That's coming back today hard and heavy. Okay. Now, I'm going to teach you a very, very easy way in case some of you forgot, don't remember, etc. And it starts with this paper that I'm going to give you. Pass it down. Pass it down. See if I gave y'all enough. Did I give? Oh, was I perfect? Oh, spot on the money for the front row. Be quiet, Vivian. No one else.
Vivian's right.
Wow.
All right. Hey, this unit is very, very math heavy. So every single day up until spring break, you need to have a calculator, your periodic table. Okay? Every single day from now until spring break. If you do not have a calculator and you need to borrow one of mine, speak now.
My calculator is rough. She's been
Because I'm poor, Reagan. Stop it.
She's also.
Does anybody need to borrow a calculator?
No, mine's poor.
I got bored one day.
Anybody else? Going once. What?
So that's in my way.
I don't know if this is a good thing, but Kaylee over here just said that
Who's
I was
Kaylee?
the embodiment of a unicorn from Bluey.
Oh.
No, not intentionally.
Boy's like 23.
Okay. Hey, some vocab here. Y'all just wrote about the word theoretical yield. Theoretical yield, do not make it harder than it is. I know it sounds new and it sounds really hard. Theoretical yields are the final answer to every stoichiometry problem. We're going to do a problem, and I'm going to introduce that word. I'm going to use it a lot, and you're going to see the words theoretical yield a lot. And we'll talk about on Monday and partially on Tuesday the difference between theoretical and actual. But just to give you a little vocab, okay? Theoretical means final product. Hey, write down this example. For those of you at home. And if you missed the first slide, there it is.
Why is this pen red?
Clean it up. I don't want any ants on my floor. You could have said 5-second rule.
So, no. You don't know who's
In this classroom?
Yeah, in this nasty classroom.
Okay, whoa. Why are we throwing shade at my room?
There's so much mystery.
You know what? You have like spilled all over the ground.
Yeah,
But only up here.
So,
Okay.
You know what that brown stain is?
No, I hope that was there when I got here. I don't think I did that. Hey, look, the green stain that was here is almost completely gone.
Watch your book again.
It was my tears.
That was from some copper chloride solution.
It was Claire's tears.
Yeah, they made them go away. Dude.
Hey, let's read this. Question is, what is the theoretical yield in moles of oxygen gas when 194 moles of sodium chlorate decomposes into oxygen and sodium chloride? Hey, first things first, we need to find a chemical reaction. That's what stoichiometry is all about, looking at a chemical reaction. Our first step is always going to be to find a balanced chemical reaction. Luckily, we are professionals with chemical reactions now. Shout out to third period. They had a 94%, 93% test average on their last test. Let's do a little translating and figure out what my chemical reaction is going to be. So right away, I see the word decomposes. What kind of chemical reaction do you think we're going to have? Oh my goodness, please. Decomposition, right? Decompositions, we know one thing on the left, two things on the right. It looks like for here we have sodium chlorate decomposing into oxygen gas and sodium chloride. Hopefully you can right away see that this is not balanced. I'm not going to waste a lot of time today working on balancing. If balancing is still something you're having a really, really hard time with, you need to come talk to me so we can get you caught up. But for those of you that are good at balancing, hopefully you saw that this is a 2-3-2 for balancing. Or 2-2-3 if you wrote it backwards. Hey, but that's only the first part. We have a balanced chemical reaction. But look, now we have numbers involved. Now we need to figure out what are our numbers telling us? Where do they go in my reaction? The very first thing it says is, what is the theoretical yield in moles of oxygen gas? Hey, so this is how I write my stoichiometry problems. It's important you follow my steps, do what I do. I'm looking for moles of O2. Do we all agree with that part? I get that from reading the problem. This is how I denote that. I'm going to write question mark equals moles right underneath my O2. That tells me that's what I'm solving for. Hey, but then I have a given. It also says that we have 194 moles of sodium chlorate. So I'm going to come under here and I'm going to write 194 moles for sodium chlorate. So far, do we see everything that I've gotten and where it comes from? Hey, look at that piece of paper I gave you. This is your stoichiometry roadmap. It's going to be your heart and your soul for this unit. This tells you exactly what process to go through for each of the different types of conversions that we might need to do. Now, I'm going to tell you now, and I'm going to break your hearts, and you're going to hate me and want to stab me in the chest. You do not get this on test paper. I'm telling you now.
1 mole of punk.
We are going to do a lot of practice problems. And there is a really, really clear pattern that most of you will pick up on. Okay? What?
Oh, we got a note card on test day?
No, not for this
What?
one.
What?
You won't need a note card for this one.
But isn't it over both?
It's next Friday, before spring break.
But isn't it
I won't be here.
Huh?
I won't be here.
And you'll either take it the Thursday before, or you'll take it the Monday when we come back.
I'm leaving early, so on Thursday.
But isn't this one going to be over?
You got to take it at some point, my
No,
friend.
I know. I'm just telling you.
Claire, you're taking it on Monday.
So, hey, looking at your paper, let's dissect this a little bit. On the very left-hand side, what does that talk about? Look at the thing in the top left. Somebody read the very top left hand. Starting point for the what? Starting point of the knowns. The ending section is the side on the right. It's the ending point, aka your unknowns, the thing you're trying to solve for. Those arrows point you in the direction to each ending point that you can get to. And it tells you what conversion you need to do for each step. Hey, so where do you think we're going to start here? Look at it. On the very left, it says molecules, moles, grams. Does everybody agree? In the bubbles. What unit am I starting with? I'm starting with moles. So which spot am I going to pick to where I'm going to start out on the paper? The moles button, right underneath the starting point. Does everybody agree with me so far? Do you agree with me? Okay. Hey, there's an arrow. Does everybody see the arrow? It points you directly where to go. Okay, keep that in mind. Hey, our starting point, we're going to start with whatever it is that we're given. In our case, we're given 194 moles, so I'm going to start there. And I'm going to draw my grid. My grids are really, really important. It's really, really important you get very, very comfortable and really, really good with my grids. Hey, looking at my grid, do everybody see how it's kind of top and bottom, top, bottom? We all kind of see that? Hey, your units will always get dragged diagonally and to the right. So if I have moles of sodium chlorate here, well, I'm going to have that exact same thing in the diagonal and to the right box. So here I'm also going to have moles of sodium chlorate. Hey, if you don't believe me, look at your paper. Your paper, we started at moles, and it's guiding you directly to the next conversion. And it says that next conversion, tell me if you agree, is moles of unknown over moles of known. Do we all agree? Hey, what's my known here? We said our known was sodium chlorate. So we have moles of sodium chlorate on the bottom. You can get that from your paper or the diagonal drag. Hey, what's going to go on top of moles of sodium chlorate? According to your paper. Moles of unknown. What's my unknown here? Oxygen, the thing I'm trying to solve for. So we're going to have moles of O2 here.
Is that moles of NaClO3 just on the mark, like in the middle? Is it just on the mark?
No, it's for this like Q, like
Okay.
section. I just write it really far to the right so it doesn't get in the way of my numbers. Speaking of numbers, I need to figure out where do I find numbers for this step. This step, I don't know my numbers. Hey, you wrote on your introduction slide exactly where to find it. Everybody look at your introduction slide and read with me. You wrote when moles of a compound is over moles of another compound, use the balanced coefficients. So if I look at my balanced equation, for moles of O2, what number am I going to use? 3. For moles of sodium chlorate, what number am I going to use? 2. Hey, the way that I check if I'm done or if I need to keep going is if the top right most unit is the thing I'm solving for, then I'm done. If it's not, I keep going. In this case, am I done? I'm looking for moles of O2. I have moles of O2. I'm done. Then this simply becomes a matter of punching numbers in your calculator. You're going to multiply everything across the top. So in this case, we'll have 194 times 3. Then you're going to multiply everything on the bottom. In this case, it's just a 2 by itself. Punch that in your calculator and tell me what you get. Hopefully you got 291 moles of oxygen. Make sure you remember your units. We cannot have naked numbers.
Are you always going to take the coefficient? Is that what's going to be done?
Well, it might not always be the first step, but you will always, every single stoichiometry problem have a step where it's moles to moles. Every single stoichiometry problem will have a step, moles to moles. Okay, it just will either always be the first step or the second step. How do we feel so far? Hey, let's do another one. $394 grams of silver sulfate reacts with excess sodium bromide to produce aqueous sodium sulfate and produce solid silver bromide. What is the theoretical yield of silver bromide in moles? I'll give you a second to write before I keep moving. Hey, there's still a crushed up goldfish on
I
your desk.
know. I can't pick crumbs up with my hands.
All right. Hey, first things first, I need a balanced reaction. If you're working ahead of me, hopefully this is the reaction you got. We have, silver sulfate reacting with sodium bromide to produce sodium sulfate and silver bromide. Hey, am I balanced? No. I am not. Gosh, dang it. Left my arm calmer in my car. All right, so look, I have 2 sodiums here, which means I need 2 sodiums there. Now I need 2 bromines over here. Now I'm balanced. So we have a 1, 2, 1, 2. Let's assign my numbers. What's my given here? Crickets I get from the crowd.
Wait, you're given
What's
your
my given?
Equation.
What's my given? What's my first given number?
394 grams of NAG, 2004.
394 grams of silver sulfate. What am I solving for?
AGBR.
I'm solving for AJBR, but what am I solving for? Is it moles, grams, or molecules? Moles, right? It tells us moles. I always start my stoichiometry problems with my given, which in our case is 394 94 grams of silver sulfate. Hey, look. Hey, look at what we're starting with this time. Now we're starting with grams. Hey, look at your Stoich roadmap. Look for grams on the left. Hey, this is a new starting point. I have an extra step here because look, on that arrow, there's a new conversion we need to do just to get to moles. I have to get to moles before I do anything else. What's that conversion according to your roadmap? One mole of known over the molar mass of our known. Hey, what's the unit for molar mass? Does anybody remember? Grams? Question mark? Grams? Hey, so molar mass means grams of my known. So we're going to have grams of Ag2SO4. And your paper says we do molar mass on the bottom with a mole of our known on top. Hey, does anybody remember how to find molar mass of the compound? Molar mass of the compound, we just break the compound up into its elements, find the masses of each one, and add them up. So in our case, we're working with silver sulfate here, Ag2SO4. Well, I'm going to break it down into each of the elements. In this case, we have Ag, S, and O. Hey, looking at your periodic tables, what's the mass of silver? Ag. The mass of silver.
107.87.
107.87. But how many silvers do we have?
You have 2.
We have 2 of them. So what do you think I need to do that number? Multiply by 2. What's the mass of sulfur? 32.06. How many do I have? Just 1. No multiplying. What's the mass of oxygen?
16.00.
0.00.
Oh.
How many oxygens do I have? 4. So what am I going to do? Plug that in your calculator. Tell me what you get. Does anybody agree? I agree. 311.80 grams. So that's my molar mass of silver sulfate. That's the number that I need to put here in my grid. Is everybody following so far?
Do you have to put the O on the end?
Technically, yes, but I'm not going to count you wrong if you don't. Good chemistry says yes. What? Hey, do I need to keep going or am I done?
Not done.
I'm not done. Right now I'm at moles of silver sulfate. I need moles of silver bromide. That means I need another step. Hey, look, without even looking at your roadmap, everybody look at me, everybody look at me, everybody look at me. Hey, I find moles of silver sulfate up here. What am I going to have down here? Moles of silver sulfate. The units diagonally drag. AKA, they always go down and to the right every time. Just like here we had grams of silver sulfate, we had grams of silver sulfate here. If I have moles of silver sulfate here, well, I'm going to have moles of silver sulfate down here. Hey, according to your roadmap now, what's going to go on top of this guy? What step are we on? We're in the box. Hey, that's the mole to mole conversion. That's my favorite step. You know why it's my favorite step? It is in every single stoichiometry problem you will ever do. That's why it's in the box. It's in the middle, because it's the most important. It's in every single stoic problem we do. Make sure you recognize that. So if I have moles of silver sulfate on the bottom, what am I going to have on the top? Moles of silver bromide. Hey, and if I have moles over moles, where do I get my numbers? Balance coefficients. Which one's going to be the balance coefficient for silver bromide? I see a 2. What about for silver sulfate? Hopefully you agree that it's a 1. Am I done? I have moles of silver bromide in the top right. I'm looking for moles of silver bromide. I'm good to go to start my calculating. Multiply everything across the top, divide by the bottom. Tell me what you get. Oh, does everybody's number at least start with 2 point something? Hey, but what do I need to do? I need to look for sig figs. How many sig figs is my final answer going to have here? 3, because my given had 3 sig figs. So my final answer should be 2.53 moles of silver bromide. How do we feel after that? Right now, on a scale of 1 to 10, I'm looking for you to be about a little or about a 5. If you're at about a 5, you're on pace. Huh? Yeah, 394 times 2 is 788, not 798.
Exactly.
All right, hey, I've got a lot more examples to do. We're going to try and do 4 of them today and try and do 4 of them tomorrow. So let's look at number 3. Am I good to erase this?
It's okay.
Start calling you Dragon Lady.
Why?
After Toothless.
Oh.
From How to Train Your Dragon.
Okay, that's
That's
Reagan, don't even, bro. Your name is
Come on, Vivian,
Stop.
start writing this down.
I don't even know what to do.
You're writing the number 3 down.
Trying to get my.
Wait, Mr. Meat. When are we done?
Please remember you're recording.
What?
Please remember we're recording.
No,
Before you ask me a
Crazy.
question.
There has to be one.
No, like when. So we finished this lesson on.
We will finish this lesson tomorrow. You'll have homework tomorrow.
No, I mean like everything that's gonna be on the test. Like when are we finishing?
Next Tuesday.
Let me just put my thinking cap on.
So like, how much harder does it get from here?
Not very.
Okay.
So
No, I'm
like,
just trying to figure out when I can.
here's what's gonna happen. This is essentially just gonna keep building on itself. So like we'll get longer conversions. So the longest conversions are 3 steps. So far we've done a 1 step, we've done a 2 step.
So it's like how we were doing mole original.
And we don't have block periods next week, right?
Which is so stupid.
No, we have block day on Wednesday,
But not on Friday.
but not on Thursday.
That's so stupid.
Why don't we have one? So why do we never have IRP anymore?
I know. I need IRB.
So the reason for next week is because of the career fair on Wednesday,
Which is stupid.
I hate that.
and
So
then
we might not be able to
this
get our
week it was because of
speech till Thursday, and I'll be
SAT. Did we have
fine.
IRP last week?
No.
No, we had IRP. We had some of IRP because they were doing.
Oh yeah, the musical.
There's
Yeah.
like 5
Yes. Yes.
Wait, Mr. Mead, I can take it. Can I take it in class Thursday? Next Thursday.
If you want, I guess.
Why
We're-
won't-
Well, we're gonna be doing a lab on Thursday. So
I'll
you're
be
gonna
gone.
still
I'm
out.
leaving at 12, so I won't even be here for study hall.
Where are you going?
Elkhart. I have a swim meet.
Hey, let's read this. 6.7 moles of H3PO4. That is called phosphoric acid. Reacts with excess sodium hydroxide to produce aqueous sodium phosphate and liquid water. What is the theoretical yield? What is the theoretical yield of water? Hey, first things first, what do I need? I need my balanced reaction. I need my chemical reaction. Hopefully y'all are pretty good at translating.
I always think there's an A. But I think I just can't spell.
I'll know what it means. Y'all might not know.
To balance this, we have a 1-3-1-3.
Yeah, that's. No. I haven't spelled yield.
To balance it, we have a 1-3-1-3. If you disagree with me, please tell me. Hey, now I need to figure out my numbers. I need to put my numbers where they belong. What is my known here? What's the number that's going to be with my known? Moles of what? H3PO4. That's important. You have to make sure you clarify what compound you're talking about. So in this case, we have 6.7 moles of H3PO4. What is my unknown? What am I solving for? Molecules. I need molecules of H2O. Hey, y'all remember this number from last unit? It's back. Avogadro. Very good. Avogadro's number.
No, great. It isn't avocado.
Yes,
She's
it
smart.
is.
You freaking ginger.
Whoa!
She cannot hate on me. She wants to dye her hair red.
Not that red.
Don't,
That's like
you
a-
can dye it my color or Eli's.
No.
All right, hey, let's make our grid. Making my grid. What am I going to start with? What do I always start with my stoichiometry grids? With my given. So we're always going to start 6.7 moles of H3PO4.
You're wrong, though, Rick.
Hey, Vivian. Be quiet.
Oh.
Okay, so.
Clock. Otherwise, I'm going to separate you and Reagan.
Reagan just talks so much I can't focus.
I'm gone.
Not Reagan Ferris, Reagan Clark.
Hey, so look, hey, before I even move on, before I even look at my paper, what's going to be my unit down here in my first step?
Boy, I don't know.
Moles of what?
Ah.
Moles of H3PO4. Without even looking at your paper, how do you know that? It's a diagonal drag. Every time we have a diagonal drag. So we'll have moles of H3PO4 in the bottom. Hey, I'm starting at moles according to your roadmap. I have moles of my known on the bottom. What's going to be on top? Moles of my unknown. Very good.
I'm not closing my circle anymore.
My unknown here is H2O. How do I find my numbers if I have moles over moles?
Your big numbers.
Balance coefficients. What's going to be my moles of H2O number?
3.
Tree. What's going to be the moles of H3PO4? Own. Am I done or do I need to keep going? Why do I need to keep going? We need molecules. We only have moles. So now I'm at my mole to mole ratio. I'm at moles. How do I get from my moles box, from my middle box, to molecules?
You're 6.02.
I need 6.02 E23 on top.
Hot new bomb chum has entered the battle.
What's going to go on bottom? 1 mole of my unknown, which in this case is water. Hey, let's talk about this E. Have y'all seen this E before?
No.
Okay, if you've not seen this E, allow me to do a crash course. If you have this kind of calculator, follow what I tell you to do. Hey, this is how you type in an E if you've never done this before. You're going to first type in your 6.02, 6.02, just like normal. You're going to hit the second button in the top left, and then the button above the 7. And that will give you an E. Then you type in your 23. And then you can just multiply the rest of it. Okay, so we'll take 6.02 E23 times 3 times 6.7. Do I need to divide by anything?
No.
Nope, because 1 times 1 on the bottom. Hey, your final answer. Somebody tell me what you got. Why is it just 1.2? 2 sig figs. Hey, but it's not just 1.2. You should have a times 10 to the number at the very right-hand side of your screen. For y'all, it should be a 25. Do we agree? Yes. Hey, I will take 2 ways to write this. The first way, and my way that you're going to see me write a lot, is the E method. So I'm just going to write E25, and I'm okay with that. You could also write the longhand way, which is the times 10 to the 25 way. Either way, make sure you also have molecules H2O. Okay? And that would be my final answer. Yeah. Yeah. Hey, what time do you get out of this class? Huh? 35? Okay, we'll stop there for the day. Peace. See you tomorrow. Sorry, I know this might be a little crooked. I think there's something wrong with the tripod, but I don't know.
Yeah, someone's cousin.
Okay, hey, we've started part 3, or question number 4 from the notes. So if you're at home, make sure you have the notes in front of you. We have our given, which is 1.97 E23 molecules of magnesium chloride. What is my unknown? What am I solving for here?
Grams of MgNO3 too.
Perfect. We are solving for grams of MgNO3 to magnesium nitrate. I need to set up my stoichiometry grid. Hey, everybody get at your roadmap. Put your finger where we're going to start. I want to see it. Where are we going to start here? Hopefully your finger is on the very top left where it says representative particles, because we have molecules here. With our stoichiometry grids, we always and forever start with our given. So we'll have 1.97 E23 molecules of MgCl2. Do not cheat me. Do not get lazy. I'd better see molecules of magnesium chloride in your work. You will lose points if you do not put that in your work.
Oh, what is happening?
Yeah.
I'm quitting because
Ada, you weren't here yesterday. You're going to be behind. I'm going to have to work with you in the middle.
I wanted to come to school yesterday, but fever came back. I'm sorry. It's not my fault.
Hey, if I have molecules of magnesium chloride here, what am I going to have down here? I'm going to have molecules of magnesium chloride. We know that because we can drag our units diagonally. Follow your roadmap. What step are we at now?
1 mole of known, 6.02 E23.
Perfect. So we're at the step where we have moles of known over molecules of known. Hey, what does it say for moles of known? Let's start there. How many? Just 1. So we have 1 mole of magnesium chloride on top. On the bottom, what does it tell us we're going to put there? Avogadro's number 6.02 E23. Molecules of magnesium chloride.
Okay. You two, you will find it for me. It's a
Okay.
chemistry.
Hey, am I done or do I need to keep going?
Okay.
I must keep going because we need to get to grams of magnesium nitrate. Right now we're at moles of magnesium chloride. So we're gonna add another step. Hey, without even looking at your roadmap, everybody look up here, 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 look up here. If I have moles of magnesium chloride here, what am I gonna have down there? Diagonal drag your units.
Oh my gosh. Wait, I look here.
What step are we at on our roadmap? Hey, really quick, I want us all to write something on our roadmap that I had 8th period write, and I think it helps them. On the mole to mole conversion box, I want you to write in big fat letters that you'll never ever miss it, the word coefficients.
Now, how do you spell that?
Anywhere in the middle box or around the middle box so that you know it goes with the middle box, I want you to write the word coefficient. For those of you that are bad at spelling, here it is.
So I do look directly at me.
I can't spell ocean.
So I said that once.
Or 3. No, I know you like you were talking about it. You can spell it.
Remember to go outside later and check the grass to see how dead it is.
In the day.
If it's super dead, I might get yelled at.
Well, no one really goes out there.
I don't understand why we can't
Yeah, no
use
one
that,
does.
like, to walk across that horseshoe.
Because that door, this door doesn't unlock.
Because it goes,
It could.
yeah.
If you want to pay for the scanner on it, there's no scanner on that door.
Well, I'm just saying it would be cool if we could, like, walk in between the horseshoe and, like, to get our vitamin C in the past.
ADS, as part of the student council, you should do that.
Yeah, you know
You
what?
should do that.
Yeah.
Hey.
Well,
Hey, so look, we're at our mole to mole conversion step. We've got moles magnesium chloride on bottom. What are we going to put on top? What's going to be the unit I put on the top? Moles of unknown. What's my unknown?
MgNO3
There you go. Moles of magnesium nitrate. Where do I get my numbers for this step? I just had you write that number. It's coefficients. What am I going to put next to moles magnesium chloride? 1. What am I going to put next to moles of magnesium nitrate? 1.
Wait, why would you put 1?
The coefficients are 1.
I flipped my MgNO3 is first.
Wait, can I see?
Am I done or do I need to keep going? I need to keep going. Hey, if I have moles of magnesium nitrate here, what am I going to have down here? The diagonal drag. It never fails.
Wait, can we only ever have 3?
Yep, the max steps you can have is 3 steps.
Okay.
Hey, if I have moles of magnesium nitrate here, where are we at on our roadmap? What do I need to write on top? Molar mass of unknown. Hey, what's the unit for molar mass? Grams. Molar mass just means grams. So we'll have grams of magnesium nitrate. How do I determine molar mass? How do I find molar mass?
Take your thingy, break it apart, use the small number.
Take your thingy, break it apart.
Really? So
we'll have magnesium, nitrogen, and oxygen. Lucy, how many magnesiums are in there?
21, well, it's 24.3.
24.31.
Oh, mine says 3.0.
Are you using mine?
Yeah.
It says 3.0 on that one. Interesting. Okay, 3.0.
Nitrogen.
Natalie, how many nitrogens do we have?
I don't know how to do that. Like, what do you mean? Which one's nitrogen? Oh, we just have 1.
But what about that 2?
So we have 2.
We have 2. What's the molar mass for nitrogen? According to your periodic tables, what's the mass of nitrogen? 14.01. How many oxygens do I have here, Claire?
1 second. It keeps standing away and I can't see. How many nitrogens?
Yep. No, how many oxygens?
Oh. 3 times 2 is 6.
6.
7.
Vivian, what's the mass of oxygen according to your periodic table?
Not from the backside of this. 16.
16. Put that in your calculator, add them up. What do you get? Reagan Ferris, what'd you get?
That?
Yeah.
148.32.
148.32 grams. I agree. If when you're typing that in, you're calculating, you're not getting 148.32, we need to talk and figure out why you're not getting 148.32.
Wait, so what do you put on the bottom for the moles of magnesium? Do you just put 1?
What's your roadmap say?
Yeah.
So on your roadmap, we have molar mass over moles. So we'll have 148.32, that's what we just found, over 1 mole.
Will we get this on the test?
Nope. You don't get the roadmap.
I feel like you're joking, but also
I'm-
at the same time.
I'm being so dead serious.
Can you show me
I just like
your problem from yesterday, how you set it up? Grace,
You don't need it.
the first
Hey, am I done or do I need another step?
you have to add.
Hannah, what do you think? Am I done or do I need another step?
You apply the ones on the top and then divide it by 6.2.
Let's do it. Type that in your calculator. Tell me what you get. Multiply across the top, divide by the bottom.
I set it up the same way that he wrote it on the board yesterday.
Do I want to be sweaty at work?
Guys, I'm literally sweating. Why is it so warm in here?
This
It's
one
really
room is
humid.
never hot. Then it's hot today and I don't like
No.
This place
Did you leave your
is
room?
I almost fell asleep.
What?
I want to know why it's hot in her room.
The fume hood?
Yeah.
It is open.
Well, it's humid outside, is it not?
That's sucking air up and out, not letting it back in.
Well, it's still open outside.
So why is it so humid? It's sucking the humid air out.
Because it's only getting what's in the box. That's the whole point of the fume hood.
Yeah, open the box. What's in the box? Why is it humid to be open?
It's
A bunch
an
of acids.
evil parrot.
So why are you storing acid?
Oh my gosh, I just can't.
You should get
No.
48.5 grams of magnesium nitrate. If you did not get that, please tell me so we can figure it out.
Mr. Mead, I'm at like a solid 7.
Good.
Yeah, I don't even know.
How do you get the last number?
This number?
Doing the problem,
Yeah.
Multiply everything across the top,
Memorizing.
divide by the bottom. This is basically one really big fraction. You multiply everything on the top, divide by the bottom.
We,
Did I put it wrong? Because I got 4 point. Like I got the same number, but I just remember because I did the.
woo.
That's because in this step you didn't put E23. 1.97 E23. All right, I want you guys to try the next one on your own. Hey, if you guys feel really good after this one, I'll give you your homework, and then we'll do the other ones.
Yeah, I'll lie. I'll probably be very confused.
I will write your equation for you, your reaction.
When's the homework due?
Monday.
Bro.
Supposed to look like, my bad.
So you got 2 weeks.
I feel like you guys like the video people more than I do. Hey, so we've got 14.5 grams of this guy. We're looking for grams of this guy. To start my stoic line, I always start with my given. If I have grams of sodium hydroxide up there, I'm going to have grams of sodium hydroxide down here. If I follow my roadmap, it will tell me if I have, in this conversion, I'll have moles of NaOH up here. And it's 1 mole, in fact. The molar mass of sodium hydroxide is what goes on the bottom. The molar mass of sodium hydroxide is 39.998. If I have moles of sodium hydroxide, I'll have moles of sodium hydroxide down here. This is my mole-to-mole conversion step according to my roadmap if I'm following my roadmap. So here's where I switch compounds. So I'll go to my unknown on top, sodium chloride.
Freaking dang it, bro.
I'm balanced already because Mr. Mean's a nice guy and gave you a balanced reaction to do for your first time.
Wait, how are
So we have 101.
Can I go to the bathroom?
Yeah, take a pass. I need to keep going because I need grams of sodium chloride. If I have moles here, I'm going to have moles down here.
How'd you get 3 here? 9 point.
Reagan's like, shut up, idiot.
Maybe you just trying to understand.
If I'm paying attention to my roadmap, I'll see that I need grams of sodium chloride on top.
Oxygen?
I'll have a 1 on the bottom because my roadmap tells me. Grams of sodium chloride, I'll do 22.99 plus 35.45. Yes, I have those memorized. 7, 8.
That's such a flex.
I get 58.44. 58.44 grams sodium chloride. Punch that in your calculator. I don't have that memorized.
So you're not a big guy.
14.5 times 55 or 58.44.
This is
Everything just like feels just so sticky right now.
I know.
I get 21.2 grams.
Is that 58.44?
Yeah, 58.44.
Glad I wore shorts today. Gosh, if I was wearing short pants, I would have lost it.
I get 21.2 grams sodium chloride. Did anybody else get that?
Later Vivian problem.
Yes, sir. Oh, that was that. Do we feel like we need another one?